Okay, we're going to have a look at May 2010 C2, question 9, that's the circle question of this particular paper. We've got the equation of a circle, and part A says find the coordinates of the centre of the circle and the radius of the circle. Okay, very straightforward. Okay, restructure that equation. So you get x squared minus 8x. Then you put the y quantities, so plus y squared plus 2y. And then I would suggest you take all the number terms to the other side. So we put equals, take the plus 7 over, you get minus 7, like so. Take the first two quantities, x squared minus 8x, and I suggest you now apply completing the square technique to it. If it's x squared minus 8x, it must be x minus 4 inside the bracket, the minus 4 being half of the minus 8x, of the minus 8. Okay, if you were to expand this out, square the first, you get x squared, multiply the two together and double, you get the minus 8x, but you'd also get plus 16 when you square that. So that is not the same as the line above, so to compensate you have to take away that 16. Now that expression there is the same as x squared minus 8x. Do the same thing for the y's, so we're going to get plus y squared plus 2y is the same as a bracket squared. It must be a y because it's y squared. Because it's plus 2y, it must be plus 1, half of the plus 2. Imagine squaring it out, square the first, you get y squared. Multiply the two together and double, you get plus 2y. But you also get plus 1 squared, which is 1. So that thing there is plus 1 too much compared to that. So to compensate, you take away 1 equals minus 7. So that thing there is the same as y squared plus 2y. Okay, let's just tidy up now. So you're going to get x minus 4 squared plus, then you put the y bracket, and now you take all the numbers to the other side. Minus 16 minus 1 is minus 17. Take it to the other side, becomes plus 17. Plus 17 minus 7 is 10. So we get it in the bracket notation. Once it's in this notation, I can say that the centre point A has got coordinates, well, if it's minus 4 there, it's going to be centre 4, and if it's plus 1 there, it's going to be minus 1 there. So we've got the centre of the circle is 4 minus 1, like so. If it's 10 on the right hand side, well, that value there is r squared, so r must equal to root 10. So there you go, we get the centre of the circle is 4 comma minus 1 and the radius is root 10. I think just for reference sake I'll make a note of those at the side of the page in case I rub these out and use them later. Okay, so there's the centre and the radius. Part A, 3 marks done. Okay, part B. Part B now says we've got a point P which has got coordinates 7 minus 2, and it says part 1, verify that P lies on C. Well, we've got the equation of the circle, there it is. If I take the left hand side of the circle and I work out what the left hand side will give at 7 minus 2, in other words when x is 7 and y is minus 2, if I substitute those values in and work it through, I hope I'm going to get the answer 10, because if that is so, then the left hand side will equal the right hand side, and so therefore point P must lie on the circle. So here we go, left hand side, x minus 4 becomes 7 minus 4 in a bracket squared, 7 being x, plus y plus 1, that's minus 2 is y, plus 1 squared, equals 7 take 4 is 3 squared, plus that is minus 2 plus 1, that's minus 1 squared. So you get 9 plus 1, you get 10. So by putting in the value of x and y for the point P, you can see that the left hand side of the equation of the circle is 10. Well, that's exactly what the right hand side is. So you're getting 10 equals 10. So this left hand side is equal to the right hand side. So therefore it must mean that the point P that we're subbing in actually does lie on the circle. If the point P didn't lie on the circle, you'd get two quantities which were not equal to each other coming out from this. Okay, so therefore we can say, therefore P, which has got coordinates 7 minus 2, lies on the circle C. Okay, that's part 1 done. Okay, the next part, it says, given that the point Q is such that P to Q is a diameter of C, find the coordinates of Q. Right, now, it's starting now to get a little bit more confusing. So, what I would recommend, since you know the actual coordinate of the centre, you know the radius, and you've been told here now a point P, 7 minus 2, and another point now Q mentioned, it might be an idea at this stage to sketch a picture of what's going on, to get a feel for what's going on, which will then make the actual calculation for part 2 quite straightforward. So that's what I'm going to do, a little sketch. So if I get rid of all of this, I've made a note for reference about A, the centre. So if I do a quick sketch of the situation, it doesn't have to be a really accurate picture, as long as it gives a reasonable representation of what's going on. I need to be able to plot 4 minus 1, so 1, 2, 3, 4. I also will need to plot the point P, which is 7 minus 2, so 5, 6, 7. Make sure, if you want to do an accurate picture, that you're using the same scale on the x and the y axis, otherwise you won't get a circle coming out, you'll have some sort of ellipse, like an oval shape coming out, so make sure you do that. Okay, the centre of the circle 4 minus 1 we discovered, which is there. Well, I'll just make this a little bit clearer. That's the point A, well that's 4. Okay, that's the point A, the centre. The point P has got coordinates 7 minus 2, so 7 minus 2 is there. That's the point P, 7 minus 2. That lies on the circle. Okay, and you've got another point Q such that P to Q is the diameter. So looking at P, Q must be over here somewhere. Looking at that, Q must be over there. So you've got that sort of thing going on, where A is the centre, P's down there, and Q's over there. It's only a sketch, it's not accurate. You get no marks for doing anything accurate. It's the mathematics of the algebra of the situation that's going to get you the marks. Okay, given that the point Q is such that PQ is a diameter of C, find the coordinates of Q. Okay, so we know point P, 7 minus 2, A's got the coordinates 4, where we 4 minus 1. We need to figure out what the coordinates of Q are. Okay, well, there are a variety of ways you could work out what the coordinates of Q are. One way would be, I suggest, that to go from P to A, it goes from 7 to 4, so all you're doing is you're counting 1, 2, 3 steps to the left, and then it goes from minus 2 on the y to minus 1 on the y, so that means you've counted 1 up. So you're going 3 left, 1 up. So if you carry on and go 1, 2, 3 left and 1 up in your picture, it'll take you to the other side of the circle in the same way. And that will take you to point Q, which, if you look at your picture, is going to be 1, 0. Okay, so therefore, and this is B part 2 now. Okay, B part 2, by counting 3 left, 1 up, 3 left, 1 up, you can see that the coordinates of Q must be 1, 0. Okay, like so. Now you might say, well, is there not a more formal algebraic way of doing this? Well, yes, there is. You could use, to get this point here, the midpoint formula. Okay, if you wanted to. Instead of doing 3 left, 1 up, 3 left, 1 up, you could have used the midpoint formula. If you remember, the midpoint formula is m x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, well, I know what the midpoint is. I know what the p-value is. It's the q-value I don't know. So we could use that formula in the following way. For a, I know what the x-coordinate is, the midpoint. So I know that x1 plus x2 all over 2 is equal to 4. Okay? Because I know what the midpoint x-coordinate is. x1, well, I could call the x1 the 7 of the point P. So that could be x1, y1. So I would have 7 plus x2, the q I'm going to call x2, y2. So x2 is what I'm trying to find. Divided by 2 equals 4. So we get a little equation coming out. If I double both sides, you get 7 plus x2 is equal to 8. So x2 is equal to 8 minus 7. So x2 equals 1. Well, we did say, just by counting 3 left, 1 up, that the x-coordinate of point Q must be 1. And that's proven it. If I use the midpoint formula again in a calculation for using this here now, the midpoint, point A, has a y value of minus 1. So I could say that y1 plus y2 over 2 equals negative 1. Okay, y1, I know it, it's minus 2. Minus 2 plus y2, that's the y coordinate of Q, which I'm trying to find. Divide by 2 is equal to negative 1. So we get that equation coming out. Double both sides, minus 2 plus y2 is equal to minus 2. So y2 is minus 2 plus 2, so y2 equals 0. Exactly the same answer that we got by counting 3 left, 1 up, 3 left, 1 up. Okay, so therefore you can say that the coordinates of Q are 1, 0. I've got to say to you, if you look at the exam technique or the exam mark scheme that the examiners provide, they prefer you to do it by this long-winded method with the algebra. I don't see any reason why you can't actually do it this way, provided you demonstrate to the examiner what you're doing. 3 left, 1 up, 3 left, 1 up, and it's crystal clear that you're doing that. I would not just slap that down without any thought about it. Show 3 left, 1 up, 3 left, 1 up, or if you prefer, show those algebraic calculations. There you go. We've found the coordinates of Q. So we've got another 4 marks there. That was all of part B. Okay. Finally, we've got a part C, which I'll try and squeeze in here if I can, if I rule that off. It says we've got a line L with equation y equals 2x minus 4. Y equals 2x minus 4, a line L. Okay. Find the points of the coordinates of the points of intersection of L and C. Right, well, what was the equation of the circle? Well, the equation of the circle, well, if that was the centre, okay, I'll actually use the equation of the circle as it's quoted in the question. I won't use the bracket notation. I could do if I wanted to. I'll use what they actually used. It's this: x squared plus y squared minus 8x plus 2y plus 7 equals 0. There's the equation of the circle. Okay, I'll just get rid of this now. Make some space so you can see what's going on. Okay, if you want to find the points of intersection between that straight line L and the circle, which is that, call that equation 1, call that equation 2, and you simply solve 1 and 2 simultaneously. Well, 1 is the linear equation, and it's already in the correct format. So all you've got to do is substitute 1 into equation 2. So equation 2 is going to become the following: x squared plus y squared. Well, y is the same as 2x minus 4. So I get 2x minus 4 all squared. Take away 8 x's. Take away 8 x's. Plus 2 y's. Plus 2 lots of y, which is 2x minus 4. 2x minus 4. Plus 7 is equal to 0. There you go. There is an equation in x which we can now solve, hopefully. So, x squared plus, square that out. Square the first. Multiply the two together, you get minus 8x. Double, you get minus 16x. Square the second term, plus 16. Minus 8x. Expand this bracket out. Plus 2 times 2x is plus 4x. Plus 2 times minus 4 is minus 8. Plus 7 is still there, equals 0. Just tidy up now. So we're going to get x squared plus 4x squared, that's 5x squareds. Minus 16x's, minus 8x, that's minus 24x. Plus 4x, that's minus 20x. Numbers: 16 minus 8, that's 8, plus 7, that's plus 15, equals 0. I'm not sure if you can see down the bottom here, so I'm going to go up here to finish it off. Quadratic equation, x squared x is number 0, fine. Before I factorise, let's share by 5. So if I share by 5, you're going to get a single x squared minus 4x's plus 3. Share that by 5, you get nothing. That should be a much easier thing to factorise. No common factor, it's a double bracket factorisation. X squared means x and x. A plus 3 with a minus in the middle must be 2 minuses. Okay, it's got to be a 3 and a 1, and if you work that out, it actually works fine. So we say that either, if you get this factorising really nicely, that should give you great confidence that you've done it right. Obviously, if you're not able to factorise it, you've done it wrong, and you'll have to quickly revisit to see if you can find your mistake. Okay, so either the first bracket equals 0, in which case x is equal to 3, or the second bracket equals 0, in which case x is equal to 1. So there are your two x values. It does say find the points of intersection, so I need to know the y values to go with it. So if x is 3, therefore I can say that y will be 2 x's take 4. 2 3's take 4. So y will be 6 take 4, y will be equal to 2. I'll just make a final bit of space, get rid of all of this, so you can see what's going on. So therefore the first point of intersection is going to be 3, 2. 3, 2 is a point of intersection. Second point comes from x equals 1. So therefore I can say that y will be 2 x's take 4, which is 2 1's take 4. So y is 2 take 4, y is negative 2. So the second point of intersection is 1 minus 2. And there you go. To do that basic simultaneous equation, to find those two intersection points, you get another 4 marks. So this question now is worth 4A, 11 marks out of 75. It's a huge chunk of marks on one question. And to be honest, you know, I think if you've got a question like that, you should be very pleased because it's fairly straightforward. Okay, that's the end of the question, May 2010, C2.